Hi, guys. All right, good morning. Happy Friday. All right, I have some notes here. In one of the assignments, there were extra problems or something. I don't know. But you are only required to do the problems that I assign. So you may see 50 problems on a page, but if I only want you to do 1 through 20, you're only doing 1 through 20. So you're welcome to do the other problems, but you're responsible for the problems that I assign in Google Classroom. Just a reminder, when you're working in the Math Wizard teams, you are to stay in the groups until you're dismissed, either at the end of the period or when I dismiss you. If you leave the groups, I'm going to mark you absent because you are required to stay in class. So just like if you were with me at Colton High School, you wouldn't just walk out of class. So we have to keep reminding ourselves that we are in class. The background noise is distracting. I know this is a very difficult situation. This is easier said than done. But I don't know if your parents really understand what's going on. So if you can explain to them that your math teacher, we're trying to eliminate noise. We're trying to eliminate distractions. We're trying to give you a quiet place to be during the class meetings. And like I said, it's easier said than done. But if you can explain to your parents, the yelling, the people coming in and running back and forth, it's all very distracting. And if we can eliminate that, that would be great. I'm also going to talk to the parents about that at back to school night. I normally don't talk to the parents, but I am going to talk to the parents about what they can do to help you to have, the optimal environment to study and listen and go to your class sessions. I want you to know that when you go into the Math Wizard groups, you do realize you can share your screen. So if you go into your online textbook and you want to do the elaborate, you can share your screen with your team members and you guys can write down problems and work them together. That would be highly effective since your online exams look like the evaluate in your interactive student edition. Just a reminder that the more questions you ask me, the better off we're all going to be. And also for exams, the more questions you ask me, the more hints and tips I give. And so it just makes you test wise. And also the book has a lot of errors in it. Some of the notations are weird. Try not to think you're wrong. Okay, try to just always think you're right. And if you have any questions, ask me. But the book, the physical book, there's a lot of errors in it. And if you're confused about a notation, just do what I do in the notes that I give you. The hotspots, a lot of people are wondering what a hotspot is. It's internet. So if you're having trouble with internet, I do recommend that you go to the high school and go to the Rancho bus loading zone and have them give you a hotspot. It's free internet, Wi-Fi. So the district is providing for it. So if you're having difficulties, please go check it out since it's free. And then finally, I am doing a workshop after school today. A workshop is a more lax atmosphere. It's not as structured as the class meetings. So you're welcome to come and ask questions about the exam or anything else. But like I said, I think that earlier, it's important you ask questions in class so that I'm not answering the same question 20 times. Now think about it. I have 120 students. I do answer the same question 20 times, so I'm not exaggerating. So please ask me in class so I can kill 20 birds with one stone. Okay, it's very important that you don't kill me off. Okay, I do like to have a couple of hours a day for myself. And right now I have no hours for myself. I'm working a lot. I have 40 emails after school. I have all kinds of remind messages. And so if you guys can, if you want to help me out, ask me questions during class. I would appreciate that. All right. Well, somebody asked me about the answers for this. And I actually stayed up last night and I did the answers. So you will find these answers in Google Classroom under answers. So this will be very helpful for you. You should have the answers to this. And so we want to thank the person who asked about this. I did do it and put the answers in your classroom. I don't think you can get less than an A. If you know how to do this sheet and you can do the right answers, you're guaranteed an A on the exam. Okay, does anybody want to ask me anything right now? All right, what I'm going to do, I'm just going to show you, I haven't put the stream in for the exam. The exam is on Tuesday morning at 8 o'clock. You have to take it then. You can't take it later. If there's an emergency, you're welcome to take it earlier, but you can't take it later. So make sure that nobody's told me there's a conflict. So just make sure that you're on top of things, set 10,000 alarms, and make sure you take that exam. Let me show you what it looks like in Google Classroom. So here it is right here. So this is exam 1112, which will enhance your overall grade if you do well. Remember, it's 60% of your grade. Exam 1112 would give it on Tuesday and starts promptly at 8 and ends at 9. So the computer will shut off at 9, the software. You will have 15 extra minutes only to submit your scratch paper to Google Classroom. To receive credit for the exam, you must submit your scratch paper on time with legible and correct work. Good luck. You do want to join the test this way. Then the reason why is because ClassLink is keeping track of all your personal information as far as username and password. So you do want to go to the CHS homepage. Let's go, ClassLink. And then when you click on my HRW, it does recognize you. So it does recognize you. You're going to sign in. Sometimes you don't even have to sign in, and you're going to select the exam right there. When you sign in, you're going to submit it. Take a photo of your scratch paper. Once again, the scratch paper, the original problem, work vertically and circle your answers, and then submit those papers to Google Classroom. Now, like I said, I am doing a workshop after school, so make sure you have questions. I am not teaching. You're coming to the workshop with questions about things. You don't have to stay the whole time. If you want to drop in for 5 minutes, you can. You do not have to stay the whole time. The only thing I ask is please be there at 2:30 so that you're not holding me up all afternoon. So just be there at 2:30 and you can leave whenever you feel like you need to. So with the exam, don't be late on Tuesday morning. Make sure you're on time. All right. Anybody want to ask me anything? Anybody want to ask me anything about the exam?
How many questions are on it?
I wrote it so long ago, I can't remember. But it's probably between 20 and 25 questions. Now, remember that the problems that there's no work required. I know that. but you do have to show all work on any work that requires steps. I am going to teach a new lesson today, and this is not lesson 1.3. It's a prerequisite for lesson 1.3. So I can't even teach 1.3 until I give you some preliminary work here. So anybody want to ask me about the exam or anything on the exam right now? Remember, I prefer you ask me questions during class. So anybody have any questions about the exam? Anybody have any questions about the problems? All right, I want to show you what I'm talking about here. What I'm going to be doing today. It is an introduction to parent functions. And that is lesson 1.3. So this assignment is an introduction to parent functions, and the content is a prerequisite to lesson 1.3. Throughout this course, we're going to be graphing various functions. And when possible, we want to be able to transform a parent function in order to graph quickly and efficiently. In this lesson, we will primarily focus on the transformation of quadratic functions. Now, if you notice, look at all this stuff I put in here. So I'll just show you, and then I'll teach what I want to today. So this right here, these are some of the parent functions we're going to look at. And so if you can print this out, that would be advantageous. This right here is the linear function. I am going to be teaching also, so I'm just showing you this. This is the quadratic function. Remember, functions pass the vertical line test. This is the cubic function that looks like a snake. This is exponential growth. This is a rational function. That's a step function, which we probably won't cover. This is absolute value function, square root function, cube root function, logarithmic function. This is another rational function. And there's even other functions that we're going to study that are not on this sheet. So these guys are the parents. Now, parents means the most basic graph. I also provided this sheet, which is absolutely essential that you know. You're going to see me do a lot of examples today. But this right here is a good summary of some things I'm going to be talking about today. This right here is actually a paper that I wrote. It's about 12 pages long, but it's the first page. I just want you to know now that there is a form 1 that you have to follow this order, and there's a form 2 that you have to follow this order. If you do not follow the proper orders, you will get the wrong graphs. And someone from the district one time said in a message, well, we all know that to do transformations, you follow the order of operations, and that's not true. If you follow the order of operations in higher level math classes, you're going to get the wrong graph. So you have to follow a specific order if you want to get the right graphs. And I provided some practice, which we will look at later. And I provided some graph paper if you want to duplicate this graph paper, or if you want to get your own graph paper from the 99-cent store. It's highly recommended that you get graph paper. Otherwise, it's just going to be tedious drawing these graphs all the time. All right, so anyhow, I just wanted to show you what I included in this lesson. And now what I want to do is I want to do this introduction to parent functions. Make sure you take good notes today. These are very important notes. The reason why these are important notes is because today I'm going to talk about the quadratic parent, but if you understand the quadratic, you're going to understand the exponential growth parent. You're going to understand the logarithmic parent. You're going to understand the absolute value parent. You're going to understand the cubic parent. You're going to understand the cube root parent. So there's 15 to 20 functions that you're going to already know after today's lesson. All right, so the parent is the most basic graph. So the parent, you don't see any numbers. So if you have f of x equals x, that's the parent of the linear function. F of x equals x squared, that's the parent of the quadratic function. That's the parent of the cubic function. That's the parent of the square root function. And that's the parent of the absolute value function. So you notice that they're just real basic, and that's why they're called the parent, because other graphs are derived from the parent. So with all of these guys, they have a special graph. So whenever you see an x cubed, it always looks like a snake. Whenever you see an x, like I was saying the other day, it's always some type of line. Whenever you see a square, it's always a parabola. Whenever you see a square root, it always goes off to the right somehow. An absolute value always looks like a V. Now, I'm just using these as examples. There's many more, but these are, I just wanted you to see how, depending on what the function looks like, is its corresponding graph. You guys, as I go through this lesson, if you have questions, please just interrupt me. This is going to be critical that we clear up problems as we go along here. So if you have any questions as I go along, make sure you stop and ask me. So there you go. There's the form for the quadratic function. And the California Common Core State Standard says that students will know what A, B, H, and K do to the parent. So remember, this is the parent of quadratic. And see this square? If this H was a 0 and that B was a 1, it would be x squared. So that's why it's the quadratic form. So let me just show you some of the other forms. You don't have to write them down if you don't want to, just watch this. So there you go. They all look the same. So they all have a minus in it, all the A's, B's, H's, and K's. See how they're all in the same position? So this is going to be the quadratic function. This is going to be the absolute value function. This is going to be the cubic function. And this is going to be the square root function. So that's why I'm saying if you understand the quadratic, you're good to go with all the other functions. So we've already conquered half the class. I shouldn't say half the class, I'd say half the lessons. Because every time we hit a new function, you're going to have to know how to graph it by knowing about A, B, H, and K. All right. Well, in this form, whenever, here's what I want you to notice too. Notice that A and K are outside the square. They're going to be outside the cube, outside the absolute value, outside the square root. And B and H are inside the square. They're going to be inside the square root, inside the absolute value. All right, so A, it represents a vertical stretch or compression. So we're going to do some math aerobics today. You ready? Let me get my screen situated. All right, let's do some math aerobics. All right? All right, so this right here is a vertical stretch. This is a vertical compression. So I want everybody to participate. You ready? So show me a vertical stretch. Hey, Bren, I can't see you. Vertical stretch, vertical stretch, vertical compression. All right. It also reflects over the x-axis, and that's if A is negative. So if A is negative, it reflects. So everybody do this, please. It reflects over the x-axis, reflects over the x-axis. Show me a vertical stretch. Show me a vertical compression. Show me reflection over the x-axis. Show me a vertical compression. Vertical, not horizontal, vertical. Show me a vertical stretch. Show me a reflection over the x-axis. Good job. All right, now, if you're wondering, well, what makes a vertical stretch? Numbers like 2, 3, 4, 5, 6, 7. What makes a compression? Fractions, proper fractions, like 1/2, 1/3, 2/3, 7/8, 7/9, 11/16. Those would be compressions. All right, now let's look at B. B are horizontal stretches and compressions. So a horizontal compression looks like this. A horizontal stretch looks like this. All right, so let's see you do it. Let's see a horizontal compression. Let's see a horizontal stretch. Let's see a vertical compression. Vertical, vertical, vertical. Vertical stretch. Vertical stretch. Horizontal stretch. Horizontal. Horizontal. Horizontal compression. Horizontal compression. Reflect over the x-axis. Horizontal compression. Horizontal stretch, vertical stretch, vertical, 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 vertical compression. Now, this is such a stupid little thing, but students are like, Ms. Birch, that helped me so much because every time I try to do these problems, I think about your math aerobics and it really helps me. Yeah, I know. I know it's going to help. B, when B is negative, it reflects over the y-axis. So it's reflection over the y-axis. Okay, so here's how you remember horizontal, vertical. Horizontal, think of the horizon. Think of the horizon. Okay, vertical has to do with, you think about a skateboarder, a skater. You know, a skater gets vertical. So horizontal, vertical. Okay, so let me write this up here. So this one's going to reflect over the y-axis, and then we're going to practice. Okay, so show me reflection over the y-axis. It's like opening a door. Show me reflection over the x-axis. Show me reflection over the y-axis. Show me a horizontal compression. Show me a vertical compression. Show me a vertical stretch. Show me a horizontal stretch. Show me reflection over the y-axis. Show me a reflection over the x-axis. Give yourself a hand. Give yourself a hand. All right. H translates, so that doesn't change the graph. Okay, it translates left and right. Now you should know that word translate from geometry. And then K translates up and down. All right, so it's critical that you know what A, B, H, and K do to the graph. So A, vertical stretches and compressions, reflection over the x-axis. B, horizontal stretches and compressions, reflection over the y-axis. H translates left and right. K translates up and down. And notice I'm not looking at anything. I just know that like breathing. All right, so let's look at some things. Okay, so I'm going to want you to state the transformation. That's not apparent, right? It's not apparent. We know it's the parent is the quadratic. Let me change this to g of x. Same thing, still a function. So this guy's the parent, and now the parent is being translated. Now, look at your form. Your form has a minus in it, right? And we know that this isn't this H? So if this is H, isn't this right one? Because this isn't a negative one. The negative is part of the form. Look. So this graph is translated right one. What about this guy? Well, he's not in the form. That doesn't have a plus in it. So to put it in the form, wouldn't we have to write this? Because now it's in the form, right? So does this represent, take a guess, you think this is left one or right one?
Left.
Trying to confuse you here. Oh my gosh, all these look the same. No, they don't. This is inside the square. This is inside the square. Now we have a plus one outside the square. So isn't outside the square K? So what's this doing to the parent? Go ahead, I'm listening.
Does it move down?
Up one. Yeah. You guys see that? What about this one? That's outside the square, right? So do you think it's left, right, up, or down?
Down.
Down.
That's correct. That's being multiplied to the square. So if that's being multiplied to the square, isn't that A? And if we want to write this in the form, wouldn't it be this? X minus 0 quantity squared plus 0? That represents 2x squared, right? Yes, represents it. So isn't that A? What does A do to the graph? It's something vertical, right? And it is a vertical stretch by 2. Anybody want to ask me anything right now?
Do you have to do the minus 0 plus 0 every time?
No, I'm just showing you this so that you know that in your mind, this is what you're seeing in your mind. You're seeing 2 times x minus 0 quantity squared plus 0. This is what you're seeing in your mind right here. If you want to write it, you can, but you're never going to see me write it. I'm just writing it now because I'm explaining it to you. So take a guess what this would be. It's vertical, right? Vertical, what?
Compression.
Yeah, if it's a proper fraction of any kind, it's a compression. Okay, now, this one is the only one that's confusing. This is inside, right? And isn't this B? So B is tricky because you always have to take the reciprocal. So this would be a horizontal stretch by 2. So this is the only one you have to watch out for. The other ones are easy. And if you had 2x quantity squared, that's inside the square, it would be horizontal compression by 1/2. Okay, now we're going to practice a bunch of these, so don't stress. I'm only going to do about 1,000,000 of these. So, but before I erase anything, anybody want to ask me about anything that's on the board right now? If you're confused, ask me. Don't wait to ask me later. Ask me now.
I'm confused about the horizontal stretch by 2, the 1/2. Wow.
Yeah, whenever you have B, all you do is when you look at that, you're seeing 2. You have to take the reciprocal always for B. So this isn't a horizontal compression by 1/2. It's a horizontal stretch by 2. And just like this one, you're seeing a 2, but in your mind, you're seeing the reciprocal, which is 1/2. That's it.
Okay. Thank you.
Anybody else want to ask me about anything?
Wait, why is the bottom one 1/2?
Because you have to take the reciprocal, and the reciprocal of 2 is 1/2.
Oh, okay.
So like I said, when it's in this position of B, you always take the reciprocal. Okay?
Yeah.
All right. You're going to actually, when we start graphing, you're going to actually see what I'm talking about. You just have to take my word for it right now. So right now we're just stating the transformation. We still have to graph the transformation. We're not even there yet. All right, so now when the quadratic is in that form, you have to follow a certain order. If you do not follow this order, you will get the wrong graph. I'm just letting you know. Now, I know that if the Algebra 1 or geometry teachers told you something else, they haven't taught the higher level math courses. So I'm just letting you know that in the higher level math courses, you must follow this order. And if you don't, you're going to get the wrong graphs. All right, so the first thing you want to do in a problem is translate left or right if you have to. And the last thing that you always do is translate up or down. So remember, this is H and this is K. So don't ever do K first, you're going to get the wrong answer. You always do translate left or right first, and you always do translate up and down last. Okay, in here are stretches and compressions. And it doesn't matter if it's vertical or horizontal. The order does not matter. So it doesn't matter if you have two of the same. If you have a vertical compression and a horizontal stretch, it doesn't matter which one you do first. And the reflections, we're going to do here. So make sure you know this order. This order will get you the correct graphs every time. All right, you ready to try some out?
I have a question first.
Go ahead.
So, since a stretch or compression is going to be either A or B, if it's positive, you do it first, and if it's negative, you do it third, right? Or,
right.
I mean, if
so
it's
let
positive,
me just show you. You're kind of getting ahead of us, but let me just show you something. So you could have problems that look like that. So you would say, okay, this parent is being translated right 3, horizontally compressed by 1/5, vertically stretched by 2, reflected over the x-axis, and up 7. So that what I just read was the right order.
so you stretch it and then reflect it?
Yes, just like this order. So it's right 3, horizontal compression by 1/5, the reciprocal, vertical stretch by 2, reflect over the x-axis, and up 7. Don't worry about that right now. All right, what we're going to do is we're going to practice a bunch of these, and we're still not graphing. We're just practicing stating a transformation. So what I want to do is I want to share my screen and go back into Google Classroom and get out, not the graph paper, but this right here, quadratic transformation practice. So I want to get this sheet. All right, you ready? What you're going to do is you're going to state the transformation in the correct order. All right, so who wants to try number 1? Go ahead, I'm listening.
Can I do it?
Sure.
It's a reflection, right?
Yep. And it's outside the square, right? Because it's not in parentheses, it's outside the square. So what kind of reflection is it?
Is it vertical?
It's a reflection over the x-axis.
Oh, my bad.
But it is vertical. Look, remember we reflect like this over the x-axis? So reflection over the x-axis is a vertical move. Yeah. Okay, let's go on to 2. Who wants to try number 2? It looks like it's in the exact form. So what would it be?
Would it be right 4?
Yep, right 4. Right 4. Okay, number 3. It's outside the square. So this looks like a K. So what would that be?
Would it be up?
Yep, up 4. Okay, now this one right here is not in the form. It's almost in the form, but I think it should be written as x minus a negative 3. So what would that be?
Left 3.
Left 3. Right, left 3. Okay, this right here looks like the exact form. What would this be in the correct order? So there's 2 transformations. There's this one and there's this one. So what would the 2 transformations be in the correct order?
Right 2 and up 2?
Yep, right 2, up 2. Good job. Okay, right here, there's 2 transformations. There's this is not in the right form. It should be minus a negative 1, and this is some type of reflection. So what would this one be in the correct order?
It'll be left 1, right?
Yep, left 1 and
Reflect across the X?
yes, good job, good job. All right, how about this one, guys? It's not quite in the form, but we should be getting used to this plus 1. It's going to be what?
Left 1 down 3.
Yep, left 1 down 3. Okay, now look at this one. This one has 2 transformations also. So it's kind of in the form. Actually, it is in the form. So what would this be in the correct order? Now see how that negative is inside the square? So that is not a reflection over the x-axis. It's inside the square. So wouldn't this be right to reflect over the y-axis?
Yeah.
All right. What about this one, number 9?
Reflection over the y and then reflection over the y and then down 2.
Yes. Yes. Good job. Good job. Okay. Now, who wants to do this challenge problem? This one has 3. This is affecting the parent in 3 different ways. Now, remember, you're going to do your left, right, your reflections, and then your up, down, last. So who can tell me that in the correct order?
Left 3. Reflection over the X.
Reflection over the y because it's inside.
Oh, yeah. And down 1.
Good job. Good job. Okay, who wants to try number 11? Now, the negative is outside the square and the negative 3 is outside the square. So this right here really means x minus 0 quantity squared. So x minus, look at x squared. Isn't that the same as x minus 0 quantity squared? So who wants to try that one? Let's go, guys. Are we on 9 or 10?
11, I think. Yeah, 11.
Oh yeah, I'm sorry, we're on 11. Okay, who wants to try it?
Is it a reflection over the x and then down 3?
Yep. It's reflection over the x. Down 3. Yep. Okay, number 12. I'll do it. How about right 4, reflect over the x and up 2? All right, somebody else do 13. This is outside the square, so it means it's A or H, K. So it's either A or K, so I think it's K. So what would number 13 be?
Up 2.
Yep, up 2. All right, number 14. What does 14 do to the parent of the quadratic? So it's 3 things. So tell me in the correct order, what is 14 doing to the parent?
Right 1, reflection over the x, and then up 1.
That's correct. Okay, and the last one on this page, who wants to try this one?
Reflection over the x and up 3.
Yeah, good job. Okay, now we're going to do the other sheet. And if you answered any questions that time, please do not answer. So I'm going to make everyone else answer. So thank you so much, everyone who participated in that practice. But now you're not going to respond. All right. Now, even though this says quadratic transformation exam, it's not really an exam. Okay. This is just more practice. All right. So somebody new. State the transformation of number 1, please.
Right 1.
Good job. Right 1. Number 2. Somebody new?
Up 2.
Good job. Good job. Moves the parent up 2. Good job. Okay. Who wants to try number 3?
Down 3.
Yes, it is down 3, but see this little negative? We forgot the negative. So it is down 3, but we're going to do that last. What should we do first, class?
Reflect over the x.
Yes. Good job. Good job. All right. Who wants to try number 4?
Left 3.
Good job. Left 3. That's correct. Good job, Alessandra. Okay. How about number 5?
Reflection over the x, up 4.
Uh-huh. Good job. Good job. How about number 6? You can do it. It doesn't matter if you're wrong. What do you get?
Reflection over the y, up 1. Or no, left 1.
Yeah, but okay, so I'm so glad you did that, because if you do the wrong order on this particular problem, you're going to get the wrong graph. So you're right, but we just want to get the right order. This would be left 1, reflect over the y. So left 1, reflect over the y. Okay, who wants to try number 7? Come on, you guys. Who wants to try number 7?
Left 4, up 1.
Close. Close. Can anybody help out? It is left 4. It is left 4. You got the hardest part. Left 4, and then what?
Reflect y and then up 1.
Reflect x. Yeah, reflect x, because see the negative is outside. So that negative goes with A. All right, what about number 8?
Left 2, reflect over the y, up 3.
Close. That's close. You are all right, except for this should be right 2, because it's in the form. So it's right 2, reflect over the y, and up 3. All right, how about number 9?
right 3, reflect over the X.
Yep. Right 3, reflect over the X. Good job. And last but not least, who wants to try number 10?
Left 2, down 4.
Good job. Left 2, down 4. Good job. All right, now, I didn't get this far in my other class in period 3, but guess we can actually do this graphing now. So let's do what's really going to be required of you, okay? Okay, you guys have all this, you have the quadratic function form tattooed on your arm, and you have the transformation order tattooed on the other arm, right? All right. So here we go. In this assignment, you are going to follow the graphing steps. Let me just write down the graphing steps over here. Number 1, you are going to state the transformation in writing. Number 2, you're going to show the transformational points. And last but not least, you're going to graph. All right, somebody state the transformation for me, please. Go ahead, I'm listening.
Right 2.
Outside the square.
Down 2.
Down 2. Now, what we have to do is we have to figure out the parent first. So, the parent, we look at this and go, okay, who is it? Is it absolute value? Is it square root? Is it a cube root? Is it logarithmic? Is it exponential? It's a quadratic. So we know the parent. And so if we made a little input out table, and we're not going to do, you can put any points you want, but I'm going to pick the easiest points. So if I pick -1, I'm not going to assume you know this. This would be -1 quantity squared, which is a positive 1. And if you put in a 0, 0 squared is 0. And if you put in a 1, 1 squared is 1. So whenever we work with the quadratic, we're not going to derive this every time. We just know that the parent is left 1, up 1. 0, 0, right 1, up 1. That's the parent. I'm not going to graph it because I don't want to mess with it. I'll graph it down here. So the parent is left 1, up 1, 0, 0, right 1, up 1, and there's your quadratic, and that's the parent. So this is the equation or the function of the parent. These are some points of the parent, and this is the graph of the parent. So what we're going to do is we're going to take these transformational points, these parent points, left 1, up 1, 0, 0, and right one up one, and we're going to use those points all the time for the parent. And we're going to do the transformation. Now, down has to do with the y value. So what we're going to do is we're going to leave the x value alone, and we're going to move the y value down 2. Now, sometimes I believe that a lot of writing causes confusion, so I'm not going to do a lot of writing right now. All right, so you help me out. What's 1 minus 2? What's 0 minus 2? What's 1 minus 2? Did you follow that? All right, anybody want me to do that again? Speak up. Does anyone want me to do that again? Okay. All right, so you go left 1, down 1, and you go 0, down 2, and you go right 1, down 1, and there you go. There's our new function. So did we follow the steps? Yes, we stated the transformation. Yes, we showed the transformational points from the parent points. And we did a graph. Let's do a few of these. Speak up if you don't want me to erase this. Can I erase it?
I have a question.
Go ahead.
So you use the parent formula to find the x and the y, right?
I'm using the parent function to get my starting points.
Yeah, but you say
And
you
then
made
I'm following the translation. Down 2 means move y down. So this is 1 minus 2, 0 minus 2, 1 minus 2. These are the parent points. These are the transform function points.
But my question is, how you know the table you made with x, x2, and y?
Yeah.
So you would use the parent to find x and y, right?
Yeah. See the points here? Left 1, up 1, 0, 0, right 1, up 1.
All right, thank you.
Okay. Let's do another problem. And normally, I don't like to call the new functions f. I like to keep the parent as f. And so the next one, I'm going to change this. So let's call it g of x. And this is x plus 2 quantity squared. Okay, so somebody state the transformation while I draw the graph.
Left 2.
That's correct. Because this is x minus a negative 2. So this is left 2. And so what we're going to do is we don't have to do this table again. We already know the points. So we could do the table in our head. We put a negative 1 in. Negative 1 quantity squared is 1. When I put a 0 into x squared, when I put in a 0, 0 squared is 0. When I put a 1 in, 1 squared is 1. So you can come up with those points and this table in your head. So now left means x. So that means all the y values stay the same. So left 2 would be negative 2. So 1 minus 2 is negative 1. 0 minus 2 is negative 2. And 1 minus 2 is negative 1. We graph the points, left 1, up 1. Left 2, 0. Left 1, up 1. And doesn't that look like the parent shifted left 2? Questions?
How do you find the starting points?
These?
Yeah.
Left one. This is left one. From the table.
So each parent formula is gonna have their different starting points?
No. I don't different stuff. Oh, you mean if it's a cubic or quad? All quadratics have the same starting points.
Okay.
But what I was saying was you could just do that. You could get these points in your head. Watch. If you put a -1, -1 quantity squared is 1. If you put 0, 0 squared is 0. And if you put a 1, 1 squared is 1. So you can come up with these points in your head quickly. Right?
Would it be different when you have a square root or an absolute value?
Yeah. All the functions have different parent points. We're just talking about the quadratic today.
Okay, thank you.
Okay, does anybody have any questions about, so we're going to always use these starting points for the quadratic. Square root, that's a different situation. Absolute value, different situation. So every parent has different starting points. Now you do realize I could use any points I want. If I want to put a 2 in here, I could do 2, 4. If I want to put a 6 in, I could do 6, 36. I'm just using these points because these are nice. But you can use any points you want. If you want to put a 5 in, 5 squared is 25. But I don't want to graph 25 on the graph. That's why I'm not using 5. Okay, does anybody have any questions about how I'm coming up with these points?
Are two of them supposed to be the same thing, like -1 and 1?
No.
For the first one, it's supposed to be -3, 1.
Yeah, you're right. Let's do them again. Let me write down below. Okay, so our parent points are left 1, up 1, 0, 0, right 1, up 1, and you can either make a table or just remember that. All right, left 2 means -2. So -2 to the x would be -3, -2 to this x would be -2, and a -2 here would be -1. The y values stay the same. So we want to graph left 3, up 1, which I did, left 2, 0, and left 1, up 1. Thank you for whoever corrected me. That is -3. So I graphed it right and showed the wrong work. So this is what you're required to do. You're required to state the transformation, show the transformational points, and graph. Let's do another one that's harder. I'm going to erase the parent now. All right. All right, guys. State the transformation.
Reflect over the x up 2.
Close. That's not the right order. Maybe you have to follow the correct order. Reflect, you're right, but reflect x goes here.
And then up 2.
What goes here? Okay, if it was this, it would be a horizontal compression by 1/3. But it's not that. It's outside, isn't it? So what is it?
A vertical stretch by 3.
Thank you. So this is a vertical stretch. And you could say VS. That's fine. Vertical stretch by 3. And now we're going to do our transformational points. And we already have them memorized. Left 1, up 1, 0, 0, Right one, up one. Those are the parent points of the quadratic. So we're going to do a vertical stretch first. Now, vertical, you told me y, right? So the x values stay the same. And vertical means we're not going to add or subtract to the y. That's a translation when you add and subtract. That's h and k. So when we want to actually transform it, because when you do a vertical stretch, aren't you stretching the parabola up? You have to multiply. So we're going to multiply the y by 3, multiply the y by 0, multiply the y by 3. Okay, now we're going to reflect over the x. Now watch my arm. Isn't that a vertical movement? And somebody said that earlier. They said reflect vertically. Well, wouldn't that mean you negate the y? So the x stays the same and you negate the y. Negate the y. Negate the y. And then up 2 is a translation up, which means we add 2 to the y. So we're going to add 2 to the y. So add 2 is -1, add 2 is 2, add 2 is -1. It's like, holy cow, are we going to get the right graph here? I don't know. These are the final points. So left one, down one, 0, up 2, right one, down one, does that look like the parent was stretched? Sure does. Does it look like it was reflected over the x-axis and then pushed up too? Sure does. And if you want to check yourself, you could put this in the equation editor of the calculator. So the calculator, the equation editor is this y equals key. So if you hit y equals and you clear everything out of here, all this garbage, clear it out and put in the negative keys down here. This is a minus key, the blue key, but the negative key, if I put negative 3x squared plus 2, and I hit graph. So this is the equation editor. This is the graph. Can you guys see that?
Yeah.
So you can always use the calculator. You can't use the calculator. You have to graph by hand, but you can always use the calculator to check yourself. So this is what's going to be required on this exam. You have to be able to state the transformations, show the transformational points and graph. Now, I know this seems crazy right now, but you're going to be able to do this so fast. Just remember that your H and K are translations where you add or subtract. Any vertical stretch or compression, horizontal stretch or compression, you are transforming it like transformers. You're changing it from a car to a robot. You have to multiply. So the multiply is what transforms it. Adding and subtracting numbers just translate it left, right, up, or down.
So when there's a vertical or a horizontal stretch, you multiply?
For vertical stretches and compressions and horizontal stretch and compressions, you multiply.
Okay, thank you.
So do you guys want to do another one, or you want to try the hard one where you have to take the reciprocal?
Can you do another one?
Yeah. And like I said, if you understand this, you're going to get the 15 to 20 other functions right. You're going to save me a lot of teaching, so. All right, how about this? State the transformation. Now, this is B, and you do have to take the reciprocal. So what would that be?
-1/2.
Right, it's a horizontal compression. No. The negative is the reflection over the y-axis. Don't include the negative with B, with the transformation. So we would say it's a horizontal compression by 1/2. Then we would state the reflection. And then we would say down 1. If you don't understand what I'm saying, ask me. All right, show me a horizontal compression with your hands. So we're expecting this quadratic to horizontally compress. All right, here we go. So horizontal means the x. So we have to multiply the x by 1/2. So that would be 1/2, 1/2 times 0 is 0, and this would be 1/2 times 1 is 1/2. The y stay the same. Now, to reflect y, remember this was reflect y? That's a horizontal movement. So to reflect y, you have to negate the x. So this would be positive 1/2, this would stay 0, and this becomes negative 1/2. And now down 1. Down 1 means the y. And we're going to add. So these x's stay the same. Sometimes you have to add fractions. So down 1 would be -1. So 1 minus 1 is 0. 0 minus 1 is -1. And 1 minus 1 is 0. Let's graph it. So remember how to read these. Try not to read it as 1/2 0. I'm so sick of students messing this up. So try to read right, left for x, up, down for y. It will save you a lot of problems. All right, so right 1/2 0, 0 down 1, and left 1/2 0. So doesn't that look like it was horizontally compressed? The parent normally looks like this. So it does look like it was compressed. All right, so let's take it to another level. What's the domain? Go ahead, you're being tested on this on Tuesday. What's the domain?
-infinity to +infinity.
Thank you. What's the range?
It's the bracket, -1, and then infinity.
Closed on -1 to infinity. And then what's the end behavior? As x goes to the right forever, the graph is doing what?
Going up.
As x goes to the left forever, the graph is doing what?
Going up.
So you will be asked those questions at some point, so got to know that stuff. All right, questions about this? So just remember with the horizontal stretch of compressions, you take the reciprocal. Now, like I said, if you wanted to know if this was right, you could put it on the calculator. So you go to y equals and delete what we just had in there out. So clear everything out. And then put in parentheses, put in the negative key, which is white. 2, you should, if you have a calculator, you should be trying this. 2x is the black key up here. X, close parenthesis, x squared minus 1, and hit graph. All right, any questions about the calculator or any of these steps up here? All right, well, I have not put a due date on this prerequisite lesson, but you could get started on it if you want, but you have a test on Tuesday morning. This assignment is due on Wednesday night. Hold on a second. This is intro. No, I don't even have it on my. Oh yeah, it's due at 11:59 on Wednesday night. Anyone want to ask me any questions about this stuff? This is called Intro to Parent Functions. And I put the assignment in the classroom. All right, well, happy Friday. I hope you guys have a good weekend. And you can hang out with me if you want to ask me a question about anything. Yeah, I will see you if you're coming to the workshop. Make sure you send me a reminder if you want me to invite you. You have to be invited or you won't be let in. It'll work a little bit differently. You'll get an email and you're joined from your email, the invitation. Okay, so I'll see you after school at the workshop if you're coming. Otherwise, have a great weekend and I'll see you on Monday. Okay, if you want to hang out with me, I'm going to turn off the recorder. I'll see you guys soon.
Miss Birch.